is minimum cost path with teleportation. So you are given an m cross 1 2D integer array grid and an integer k. You start at the top left cell 0 0 and your goal is to reach the bottom right cell m minus 1 to n minus 1, m minus 1 and minus 1. So there are two normal moves. Like normal move, either you can go right or the down, and second is teleportation. You can go to any other cell xy from ij if it satisfies this condition. Grid of xy is less than equal to grid of ij, and that cost of moving will be 0. So we can do at most k times teleportation, which is given k is equal to 2 here. So we have to return the minimum total cost. So if in this question there was no teleportation, we would have simply used TP and we would have got an answer. But by adding teleportation, we will have to calculate the shortest path. So we will use Dijkstra's algorithm here, and we will treat each cell as the node of a graph. So let's try to code this. Let's import heap q for Dijkstra's algorithm. Now let's calculate the length. So number of rows is equal to m is equal to length of grid, n is equal to length of grid of 0. And let's do one thing. Let's create a variable infinity and store its value. So math dot infinity. For that we will have to import math. We'll have to import math. Now simply we can create a new variable cells, and we will sort this all values. Okay, we will sort this all cells by their values and install, and we will keep the value of the cell and I and j, row and column number of that particular cell. So let's do that. For I in range m, for j in range n, cells dot append, what we will append, the value grid ij and the row and column number, so I comma j. Now we would have got m cross n elements in our this cells, and now what we will do, we will simply sort this. By sorting this, let me define, see, by sorting this we have sorted cells dot sort. Now what we will do, suppose we create a variable unlocked. Okay, for range 0 for I in range k plus 1. So what will happen, this unlock list will give us how many values are unlocked. If we are, suppose if we are 3, so how many values are unlocked? So all the values less than 3 and equal to like 0 1 2 3 will be unlocked. So in teleportation we can go to any of these cells. So this will help us to keep track of that, how many values are unlocked when we have reached a particular cell of a particular value. So all the values less than or equal to that we can reach, and now we can simply set the distance. Okay, so distance is equal to set infinity. We have created this infinity variable up. So infinity for I in range k plus 1, then for I in range n, for I in range, we have created 3D matrix here to store the distance. Okay, now what will be the distance of the 0 node from the 0th node? Of course it will be 0, so we will say it as distance of 0 0 row 0 column with 0 transportation is equal to 0. Now we will simply create heap. So pq is equal to this. We will add this value heap q dot heap push. We will add in the array pq, what we will have, first thing will be the cost, second will be the I comma j comma how many teleportation we enter, so 0. Now we will simply run the loop using same like Dijkstra's algorithm with some changes. So while pq cost comma I comma j comma teleportation is equal to heap q dot heap pop from pq. Okay, now let's check if cost is greater than, if cost is greater than distance at I, j and t, then we will simply skip this, as we want the small, we want the least cost, so it's already the least cost, so we will simply continue. What else can be the case? If we have reached the end, if I is equal to n minus 1 and j is equal to n minus 1, we have reached the end, so we can simply return the cost. Yeah, and now simple like Dijkstra's algorithm, we will traverse right and down. So for ni comma nj in, so if we will go right, what will increase? Y will increase, x will be same, so I comma j plus 1. Similarly, if we go down, what will increase? X will increase and j will be, y axis will be same, so it will be j only. Now check the boundary. If ni is less than m and nj is less than n, if ni is less than m and ni is less than, we can simply calculate the new cost. So what will be the new cost? New cost is equal to cost plus the sum of the destination where we are reaching, so grid of ni and nj. Yeah, now we will check if this particular thing, if new cost is less than the distance stored at ni, nj and t, we will simply update it. Then distance at ni, nj, distance at ni, nj and t is equal to, if new cost is simply is equal to new cost, and we will add this in the heap. So heap q dot heap push, in which array to push? pq, and what to push? New cost will be the new cost, and ni nj will be the row number, and teleportation remains the same. Yeah, so now we have done for the right and the down part. Now we will do teleportation. So suppose if t is less than k, so while count of our unlocked, we have created unlock variable this list. So while unlocked of t is less than len of cells and its value, and the cells of unlocked of t, unlocked of t, that value should be less than equal, cells of unlocked of t, the second cells of unlocked of t is less than equal to the grid, is less than equal to grid I, is less than equal to grid ij. So if this is the case, we can simply take out the value, like what will be the x and the y value, getting the cells at unlocked at t, as our cells is sorted, so it is easy for us to keep track which all got unlocked. So unlocked of t, and simply we will increment the count, unlocked of t plus 1. So wherever it gets this condition fails, it will simply break the loop and come out, as that many cells have been unlocked for the values less than equal to that particular value. So now we can simply check if cost is less than distance at x, y, and now t has increased. We have done one teleportation, so t has increased, and distance x, y, distance x, y, and teleportation t plus 1, we can simply update it to the type of mistake, x, y, t plus 1, we can simply update it to the cost and push it, heap q dot heap push, where to push in the pq, what to push, cost comma x comma y comma what will be that teleportation increased by 1. Yeah, and now in what we will return, we will simply we have to return this distance at m minus 1 and n minus 1. So we will reach distance at m minus 1 n minus 1 with a different t value. So what we have to do, we have to take the minimum of all those, minimum of that particular row, distance of m minus 1 n minus 1. Let's try to run this. It's you see we have simply written math here, import math. Let's try to run this. Unlocked. Okay, it's a typo mistake. Where unlocked. Let's try to run this again. Yeah, so test cases have been passed. Let's try to submit this now. It's taking too long to run. Oh, it's passed. Yeah, so our code passed successfully. Thank you.